All right, so let's take a look at this. So we were on unit 11 last time, or slide 11. When we're doing this, the idea we're going to do now is this idea of a 45, 45, 90. Last time we did the how to do this for 30, 60, 90 triangles, and how we ended up doing how it worked out there. So now we're going to do it with 45, 45, 90 triangles. So the idea here is exactly the same. What they're doing here, by the way, is they're kind of using the Pythagorean theorem. So x squared plus y squared is going to equal our c squared. So if we're using the Pythagorean theorem, all of trig is, and trigonometry is used a lot in pre-calculus. So all of trig is just basically a triangle. So if you understand how to use your trig functions and the Pythagorean theorem, this is going to be good for you guys. So if we look here, this is just going to be a squared plus b squared equals c squared. So this is our c, our hypotenuse. But in a unit circle, our hypotenuse is always 1. So our sine is always y. Our cosine is always x because it's always the idea of that. So that's why this is happening. And this just ends up being y over x. So these are just rules. You can find them in our unit sheet, actually. I think I already pointed it out, but just to kind of review, because this is one of the rare times we're going to have a weekend in the middle. I'll try to get us back on track because I know the holiday kind of threw everything off. But let's see what we have here. So if we go to coursework and we look at our trig notes, everything we'll ever need for the rest of this class is going to be on here. And more stuff. Some of this stuff you won't see, we won't use, so don't worry too much about it. Just look for the stuff we do use. So if we look here, all of these are right here, and they even say it over 1 because it's a unit circle. All right, and let's get going. So moving on to slide 12. So trig is used whenever we have an angle and another side, but we need to find this missing side. So if we're looking here, this is going to be just a matter of understanding what sides we need. So if our angle, we use whites. So if our angle's right here, this is going to be the opposite side, and over here we're going to have our adjacent. So if we're looking at O and A, if we think about SOHCAHTOA, we're going to be using tangents. And you know what? I just realized that Thomas probably doesn't have the link to this class. So give me a second while I send him a text with the link. All right. All right. So we're going to use tangent. So that's why they're using tangent here, because they acknowledge it's opposite over adjacent. So our opposite is 3, our adjacent is that. And then they just plug this into a calculator. Or since we already know a unit circle tangent of 3 is the same thing as y over x. So what they're doing here is they take the unit circle and they're doing our y is 3 and our x would be whatever tangent of 3 is. So they're saying, what is tangent of 30? Well, tangent of 30 is our 1 over, or I'm sorry, I'm getting this backwards. They skipped a few steps here. I don't like when they skip steps. I'm not a big fan of it. They're skipping. What are they skipping here? Opposite is 3, opposite of Jason. They're just giving us this without explaining why. But if we had to explain why this was, if we look at our sheet again, tangent is y over x. Our y in this case is 3, and our x, they're not even explaining that. Oh my gosh. Yeah, we're going to end up cross multiplying, but they didn't end up showing us what it was. So that's why I'm doing this. But yes, that is a good point. What's happening here is they're going on the unit circle and they're saying 3 over, or our y value first. Sorry. We have to do our y value first. So it's 1/2 divided by this square root of 3 over 20 over 2. And then when you flip this over, what you end up getting is you end up getting the square root of 3 over 2. And then you're going to do it again. So they did a lot of work there, but you guys can honestly input it just into your calculator. How'd they get this? Opposite over adjacent, y over x, tangent at 30 degrees, y, flip it over. Oh, I cross multiplied wrong, or I multiplied wrong. This is supposed to be 1 over square root of 3. So if you do 1 over square root of 3, you're doing this 3 divided by 1 over square root of 3, which they got over here. Did that make sense? Thank you, Lily, for pointing that out. It's not really cross multiplying, it's flipping over. It's reciprocating and multiplying. But that's how they end up getting this 1 over square root 3. Then they do it again, and that's how they get this part right here. Did that make sense? I know I kind of went all over the place using this and everything. Hey, it's Nick. I was like, is Nick alive? Oh. It's okay, man. I was already telling Josh, I'm like, I think I'm just gonna put him as an excused absence because that's rough. I think you haven't really missed much. I just went over the stuff that we went over yesterday, and then we're just going over how we use these functions. And I was complaining about Edmentum, but you can always watch that part again on the YouTube video. So moving on. So trig is used a lot in finding out how tall a building is. The reason being is what we can do is we can use all kinds of tricks here. So the most common way people use to figure out how tall a building is they go from here. They're like, oh, how far am I away from the building? How far is the adjacent? And how much of an angle? They use these little tools to kind of measure the degree of how far they're measuring. And once you do that, you can kind of figure out how tall the building is. So, and this is the opposite. So they use a lot of tangents. You guys can watch this video to see more on how they figure out how tall buildings are. This one, they're showing the distance in between buildings. So tricks used a lot. When we're using it in a unit circle, we're going to assume that our radius is 1. And the reason why we're allowed to make that assumption is a unit circle has a radius of 1. So the hypotenuse has to be 1, always. All right. So they kind of go into it here on special triangles. I don't really, you just have to remember that you always kind of want to stay. I always do everything in the first quadrant. So if we think about it, any one of these triangles can be repeated. And the reason why we can repeat it is if we look at it this way, from here to here, this is a 60-degree triangle. So that's how come if we look at our coordinates, this x is the same as this x, just one's negative. So that's why they always give you kind of these parameters of when we're talking about. So when we're talking about, let's see, blah, 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 blah. We're usually talking about from 0 to 4 pi. When they say those parameters, 0 to 4 pi, they usually talk about this. Otherwise, it kind of flips over. Everything, the triangle will repeat after that. So it's just a bunch complex stuff. Don't worry too much about it. The reason why I say it repeats is now this is 30 instead of this being 30. I don't want to get too far into it because I think I'll just confuse you guys. I probably said too much already. So when we're looking at this, match which trig functions we can use. All right, so if we're talking about pi over 6, pi over 6 is dividing 180 by 6. So we're talking about a 30-degree angle. So pi over 6, we're going to divide by 6, get a 30-degree angle. So what I usually like thinking about this is, now my x value is really long and my y value is really short. Whereas if it was a 60-degree angle, it would be the opposite way. So if I'm looking at a 30-degree angle, I'm looking for a cosine that's big. I'm looking for a long cosine. And I know my options are, it's either going to be 1/2 square root of 2 over 2 or square root of 3 over 2. These are my options. Well, technically 0 and 1 also. So you do have this 0 and 1 option also. And if you notice, they're switched. Our cosine is 1 here, but our cosine is 0 here. Our sine is 0 here, but our sine is 1 over here. And remember, sine is our y value in a unit circle. So if I'm looking for this, I'm looking for my longer side. So I know that my cosine is going to be square root of 3 over 2. So my cosine theta is going to be square root of 3 over 2. My sine is going to be short. My y value is a short one. So I'm going to say my y value is 1/2. So if I'm at pi over 4, 180 divided by 4 would be 45 degrees. I just have this memorized. I didn't figure that out magically. I just have it memorized. So what this means is it's going to be square root of 2 over 2 for both the x and the y. Because 45 degrees, again, I said it repeats after 45 degrees because it's even. It's even at the x and it's even at the y. So that's why our answers are these. So this is going to be something that you guys should start memorizing, but I don't think that'll be a problem because Nick, you memorized it back when you did it in Algebra 2, right? Right. Yes, see? For those of you watching it on YouTube, Nick said he definitely did. He definitely memorized. So you guys can all email Nick with your trig questions. They can't hear you, Nick. So just remember that you just have to remember 3 values: the 1/2, square root of 2 over 2, and the square root of 3 over 2. Other than that, it's just thinking, 30 degrees, That's a small angle, which means I have a very long x and a very short y. 45 degrees. Oh, it's even. 30 or 60 degrees. Oh, that means I have a short x and a long y because it's a big angle. And that'll help you kind of determine this. That's how I memorized it anyway. It all comes with practice. So again, feel free to watch the videos on your own for the unit. It's literally a 5-second video just saying unit circle. Wow. All right. Well, we just watched it together then. What's happening here is they're just describing the Pythagorean theorem. So right here, what they're describing is a squared plus b squared equals this c squared. And the only difference is that because this is our origin, when we use the distance formula is basically just the Pythagorean theorem. So if you guys were ever like worried about this formula, plus y2 minus y1 square root d. This is literally just the Pythagorean theorem, where this is how long this is, and this is how long this is. And the reason why we're taking a square root is, according to the Pythagorean theorem, we have to square it. So that's all it's saying here. So since this in a unit circle is always going to be 1, x squared plus y squared will always be 1. That's all this slide is telling us. If it's in a unit circle, your x squared plus your y squared should always be 1. And a good way to kind of think about that, just to verify, remember I said you have only these options? So if it's short or 1/2 and long, and we know it has to equal 1, let's see if this is true. I know I did this in the first unit, but I'm doing it again. So if I do this, this changes into 1 squared over 2 squared plus square root of 3 squared over 2 squared. And this, I'm going to draw an arrow this way because I should have started over here, but I didn't think about that. So this turns into 1 over 4 plus this cancels out with this. So you get 3 over 2 squared is 4, which you get 1. So that's good proof right there, showing that this works. All right, so moving on over here. So which one of these points lies in the circumference of the circle? So I've been over this a few times. Obviously, this one can't. And the reason why it cannot is, think about it this way. If you're at 2 over 1 and the radius is 1, how can that happen? Can't happen. 0, 2, or actually it was like 2, -3. So 2, -3, that's like way out here. And 2, 0, 2, that's going to be over here. Can't happen either. And this one was a trick question. It really was. The reason why this does work is they wanted you to plug this in to the Pythagorean theorem. So if you do that, you get 5 over 9, because 3 times 3 is 9. Square root of 5 times square root of 5 is just 5. 2 times 2, 4. 3 times 3, 9. So you get 9 over 9, which is the same thing as 1. So I think this was a trick question because it does lie on the unit circle, but to be honest, we're never going to use this. We're always going to use 30 degrees, 45 degrees, or 60 degrees, or multiples of those. All right, and it's going over this again. Again, it just really wants you to think sine is our y value, cosine is our x value, and tangent is y over x. And like I said, if you guys have not printed this out, at least save it in your Google Drive or something, because it does have a lot of useful formulas. This is what I always use to teach trig. All right, so I'm going to move on here. Let me keep going. All right, so more unit circle questions. You guys excited? Very excited? Nick says he's excited, guys. All right, so is there any point on the circumference of the circle that shares the coordinate with this? So is there ever another point? Yeah, there is. There's quite a few of them, right? So if we're thinking about a unit circle, is there ever a point where we would have the same point as this over here? And the answer would be yes. That answer would end up being x comma negative y. It has the same point. So we would say, if so, what are the coordinates? Well, since we don't know what the x and y are, we're going to say, yes, there is. The coordinates, it's just asking you for the x and the y. The coordinates are negative, x, because the x stays the same, and negative y. This means that if we go, let me use yellow, if we go this way, this is going to be negative theta. So our angle is the same, it's just negative. Later on, we'll show that I don't really care that's negative. I'm like, just do it this way. And just remember, if it's in, this is something one of my pre-calculus students taught me. It's called all students take calculus. It's a way of remembering what this is, or another way of thinking of it is students all take calculus. If you want to think of it that way, I like thinking about this way: all students take calculus. It's a way of remembering what's positive. So what's positive in quadrant one? All of them. Sine is positive. Cosine is positive. Tangent is positive. What's positive on this one? Sine. Our y value is the only thing that's positive. What's up? What's good over here? Tangent. The reason being is our sine and cosine are negative. So a negative divided by a positive is a positive. And over here, only cosine is positive because our sine is negative. I don't know if that'll help you guys out, but it's just an interesting fact to know. So our x is still positive because we're on the quadrant 2. All right, so measure the angle of the point joining this, write it in radius form. What is it talking about? Measure the angle made by the radius at this point. Oh, okay. We're trying to figure out what this is. So that's what I said. Our answer would be, so we're going to use this because we need to use that theta symbol. The point, or the angle of this point is negative theta. Or if going counterclockwise, it is 180 takeaway, or 180, 360. So this is in order to give you a positive angle. So the negative theta is just by saying if we start at 0, we would go down negative theta. But if we want to go clockwise, how far are we going this way? Well, it's 360, take away whatever's there. So that's what it means. That's what I mean by negative theta or 360 minus theta. We don't know what this angle is, so we're just calling it theta right now. Does that make sense? They're saying compare these two values. Oh, okay, cool. Compare these two values. So this is asking me to compare the x values. Because remember, cosine is x. So I would say, and the reason why they're saying 2 pi is this is 360. 2 pi is 360. So they're saying 360 take away theta. They're just doing it in radians. So get used to using radians too, because Edmentum likes radians. So the values of cosine at these 2 points is congruent. You can say equal to if you guys don't like using geometry vocab. So these 2 points are equal. Why? Because cosine is the x value and the x values are the same. Cosine is the x value in a unit circle. It's not always the case. It just only works in a unit circle. That's why we learn the unit circle, because if we know the unit circle, we can apply it to anything. Let's say our hypotenuse was 5. Well, you know what you can do? You can take whatever the x value would normally be and you multiply it by 5. So you can figure out, like, let's say we have a radius here and that here, and we're like, okay, well, this is 5 and our x here, and this is 30 degrees. Well, 30 degrees, our x should be square root of 3 over 2 in a unit circle. But since our radius is 5, we just multiply this by 5. That's the beauty of doing the unit circle, is if we know whatever our radius or our hypotenuse is, we just multiply it by that number. So that's a benefit of doing that number, of using the unit circle. I'm sorry. Is that kind of making sense? You sound disappointed that now you have to remember the unit circle. All right, everybody watching on YouTube, Nick just says he loves the unit circle. It's like the best thing ever. All right. So, is there any point in the circumference that's the same as this? So you would say, yes, there is. What would that point be? So we're going to say that shares the same y value. So a point, I cannot type today, a point that has the same y value would be negative x, comma, y. What this means is I'm saying that my horizontal distance, my distance from here to there, is the same distance as this to here, only it's negative now. That's what it means by negative x comma y. All right, so according to this, what angle would that be? Oh, and it wants it in radians. See, I don't read things apparently. I'm a math teacher, so I have trouble reading. So it wants it in radians. So if I wanted to fix this over here, this would have to be 2 pi. So that's how come this threw me off, because they wanted it in radians. So if I want to do this, where is it? Well, first of all, I could cheat because Edmentum's really bad and it doesn't realize that gives me the answer right here. I could, or if I don't want to do that, I could realize that, like, oh, cool, this is 180, but we're going to take away that theta. So what I'm going to say here is the angle at which the y value is the same is, use my equation editor, pi minus theta. So that's what's our answer going to be. So in this one, how do these compare? Same thing as with the cosines. These two values are equal. I'm going to say equal instead of congruent. Are equal because in the unit circle, sine is the y value, and at these angles, the y value is congruent. So again, this is another reason why the unit circle is so useful, because if we're going a certain distance this way, this comes back down at the same rate. So if we're going the other way, so if we're going x units one way, this y value ends up being the same thing as this way if we go the same units but negative the other way. So that's another reason why a circle's so useful, is it lets us use these ideas. All right, so now we're going to be talking about extend AO to this one. B, which line represents the opposite quadrant of the circle? Extend AO over to B. What are the coordinates? So if we think of it this way, it's asking, what is this? What is this? Well, if we think of it logically, this is theta. And theta means that if the angles are the same, that means that the opposite and the adjacent have to be congruent because it has the same angle, right? So if I think about it that way, I'm like, wait a minute, that means that this opposite is the same, but it's negative because it's going down. It also means that the adjacent over here is the same, but it's going the opposite direction, so it's negative. Point to, or point B has coordinates of negative x comma negative y because it is the same length as AO, but in the opposite direction. It's the exact opposite. So if it's the exact opposite, that's why it's negative x and negative y. It's the exact opposite. What is the measure of the angle there? So if we look here, the angle is the same, except we're doing 180 plus that theta. So when we do this, the angle of point E is pi plus theta. It's the exact same thing, same angle. We go around 180 and then we add another theta. That's all that's happening here. Refer to the figure, so we don't even have to like answer that part. Compare these two values. At this point, I just think Edmentum's being lazy with their questions, so I'm gonna do this. Control C, Control V. There the two values of are, except instead of equal, I'm going to say opposite. And the y values are opposite. Are opposite. So that's what I'm pretty much doing. And it also wants me to compare the cosine. So guess what? I'm just going to copy this. And I'm going to say the two values are opposite for cosine. Because in the unit circle, cosine is the x value. And at these angles, the x values are opposite. And that's pretty much how you do these. I kind of showed you guys my little copy and paste way of doing it. I probably could have done it for part C on question 2 as well, but now you guys kind of get an idea of how I do it. And you guys are free to use your own words. In fact, you guys probably should. This is showing you what I showed you guys the first day of this unit, which was 30 degrees is just pi divided by 6. It's just 180, and we're dividing into 6 equal parts. So this is 1 6, 2 6, 3 6, 4 6, 5 6. Or if we want to look at it in thirds, 1/3, 2/3 is this other one, and 3/3. And if we're looking at the fourth, 1/4, 2/4, 3/4, 4/4. That's all that we're doing. They're just putting in really complicated things here, but it's basically saying that this and this have similar x and y values. The only difference is over here the x is negative instead of positive. So that's why I said you can always repeat the coordinates. And you can always do it here too. So A, B, D, and C, these are all the same. It's just different. So always pay attention to your theta. So if the theta is right here for this angle, it has similar y values. So looking at this one, which one of these has a value of 1/2? So if we look at our unit circle, and again, you guys are free to use this, 0.5 is just 1/2. So if I'm looking at this, I'm like, okay, cool. So here's 1/2, here's 1/2. These aren't 1/2, so these are negatives. But there is a positive 1/2 here. And if I look over here, oh no, darn it. I see that there is a positive 1/2 here. So these are the only spots that have 1/2. So we should have three answers. Cosine at 30 or cosine at pi over 6. So look over here, cosine at pi over 6. Nope. I also have one here at sine. Oh, I'm sorry. Sine at pi over 6. I'm sorry. It's the y value. Since it's the y value, it's sine of pi over 6. Sine of pi over 6. Still no. Or cosine at pi over 3. Cosine at pi over 3. Nope. Or sine at 5 pi 2/3. 5/6 of pi. Sine 5/6 of pi. Sine 5/6 of pi. Perfect. And I also have one at sine 11/6. So sine at 11/6. Cosine at 5/3. 5/3 would be over here. Not quite, because that's going to be a negative. So those should be my only answers. Incorrect. Which one am I missing? Cosine at 11. Oh, derp. I forgot the other cosine. There's a cosine right here. Wait, what? All right. 11. Why isn't this one it? Oh, this one isn't it. Derp, derp. I must have looked at this and thought they were saying the other one. So they were only looking for this one and this one because they're like, you should already know this. And both of them are negative. Our x's and y's are negative here. And then our summary. So, yay. So that's about it. Use your unit circle when you're answering these questions, but just remember what we learned here today, guys. This idea of from here to here has the same angle as from here to here, right? Also, if we think about it, this angle here is the same as this angle here. Or we can look at it this way. This angle is the same as this angle. That's gonna help you memorize the unit circle a lot if you realize, hey, everything I need to know is just in quadrant 1. Everything else is just negative or positive. And I don't know, did I go over the activity with you guys yet? Oh, yeah, I did several times because it's the one with the essay. Again, if you guys need help with your activities or anything, just make an appointment with me and we can always go over it. You guys have any questions? No? Good. So let me just turn off the record.